Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to calculate the standard entropy change for a reaction. So let's get into this. As I said before in previous videos, I'll say again that entropy is a state function. What does it mean to be a state function? So to be a state function means that your amount doesn't depend on how you got to where you're going. So, for example, um, if you want to look at the change in potential energy, right? So you could either, if I go up from, if I'm in a building, right, and or a hotel, I'm at the ground floor, and I want to go up to the highest floor, the top floor. I can do it two ways. I could either take the stairs, or I can take the elevator. So it doesn't matter which way I take, my potential energy change is going to be the same, right? So if I walk up the stairs to the top floor, I'm going to increase in potential energy the same way I would if I was to take the elevator. One requires more energy than the other, but my potential energy change will be the same, regardless of how I got there. So entropy is the same way. It's a state function, so it's only going to depend on the amount of entropy I had in the beginning and the amount of entropy I have at the end of the reaction, right? So it's only going to depend on the starting entropy of my reactants and the ending entropy of my products. And so this breaks down into a really simple equation, which I have right here. So the change in entropy, the standard entropy change of a reaction, and again, this little circle here means standard. So anytime you see that, we're referring to standard. So, and the delta means change. So we're talking about change in the standard entropy of a reaction is going to be this equation right here. So what does this mean? This is the Greek symbol sigma, the capital sigma. We use it in math to mean the sum of something. So this means that we're going to be adding things together. We're taking a sum. So this is going to be the sum of the entropy of the products multiplied by their stoichiometric coefficients. What does that mean? The stoichiometric coefficients. That just means they're multiplied by the coefficients of the substances in a balanced equation. Okay, and then we're going to subtract the sum again, the adding of the entropies, the standard entropies of the reactants, multiplied by their stoichiometric coefficients in the balanced equation. So here's an example, a generic equation. So I have substance A plus substance B are reacting. These are my reactants, and the coefficients are small a and small b, and they're going to produce substances C and D, and they have coefficients small c, small d. And so if this is my balanced equation, then the way I would use this to calculate the standard entropy change of the reaction is to then, as the equation says, I'm going to take the standard entropy of the products multiplied by their coefficients, their stoichiometric coefficients. So again, those are going to be the coefficients in the balanced equation. So for example, I have two reactants, I have two products. It's products minus reactants. So I have the coefficient small c here for this product. So I'm going to look up the entropy, the standard entropy of this substance here, substance C. I'm going to multiply that by its stoichiometric coefficient in the balanced equation. So it's going to be C times the standard entropy of the substance C. And I'm going to add to that. That's what the sum means here. I'm adding together the standard entropies of the product. So I'm going to add to that. Then the coefficient D for D, substance D here, the coefficient, the stoichiometric coefficient from the balanced equation multiplied by the standard entropy of D. And I look that up in my tables, and I multiply those together. And I'm adding these together for the total for my products. And then I'm going to subtract the same for my reactants. So I have reactant A and B. So I'm going to take the this coefficient from my balanced equation, little a, multiply that by the standard entropy of substance A that I look up in my tables, and then I'm going to add that to the substance B. So I'm going to take the coefficient for substance B, multiply that by its standard entropy that I look up in a table, and then I add those together, and it's the sum of the products minus that of the reactants. And so that would give me the standard entropy change of the reaction. And it's that simple. So one thing I want to point out is that unlike entropies of formation that we saw in another video, that in the standard entropies of formation, we saw that elements in their standard state have a zero entropy of formation. That is not true for standard entropies. So for standard entropies, they're always going to be non-zero at 25 degrees. So again, you're going to have to look those up. So the entropies of elements, the standard entropy of elements is not going to be zero. The entropies of formation will be zero, but not the standard entropies. So you got to look those up and use those, even if it's an element. Okay, so that's how you're going to calculate the standard entropy change of a reaction. In another video, I have an example. I go over a couple of examples of how to do that, so you can watch those examples. I hope this video was helpful. I hope you enjoyed the video. If it helped you in any way, please, by all means, like the video. Hit that like button right there. Subscribe to my channel. Make sure you hit that notification bell so you can be notified by other videos. Please share my videos as well. Put a comment down in the comment section. Let me know what you think and if you've got any questions. Thanks for joining me and have a great day.